Now, I request Professor So to share his 40 years of valuable research journey. He is an inspiration for everyone. Professor So. Yes.
That's good. Okay. Good evening in Singapore time is 9 o'clock. Good evening, everybody. And I want to start off by thanking Professor Suresh Bala and his team of organizing committee and all other committee members for putting all this together within such a short time and with distinguished guests, OBE from UK, the Empire, and also other distinguished guests. So thank you very much for inviting me and giving and honored me with this lifetime awards. Okay, I'd just like to start off by saying that 25 years ago, I participated in a conference, sort of similar conference dedicated to my MIT supervisor, Professor Jerome Corner. And never have I expected that 25 years later, my own student would actually put together and organize a conference for me. So I've been so touched. In fact, since he informed me, I just was so overjoyed and couldn't sleep for so many months. So thank you very much, Suresh and your team members, for putting all this together for me. I have a short biodata in my 40 pages of PPT slides, but I think you have used most of them in your little video just now, so I'll just skip through them. Since you already know my background, so I'll just skip through them and I'll come straight to my 40 years of research. Okay, basically, my first phase of 15 years was in offshore engineering. That has got to do with my background of work. As you know, I worked for McDermott, then the largest offshore company. My 40 years of research, I actually did some research in the industry when I was working as an offshore marine engineer, because that was doing very practical actual problem solving type of research. Then the university research, I continued my first 15 years in offshore engineering, but add up together is more than 40 years because there is an overlap of about five plus years within different areas, except for this offshore engineering. So into the 10th year, I went on to do computing and civil engineering. So there was an overlap. And then between computing and civil engineering, I worked on structural health monitoring, but also along the way, I applied structural health monitoring to offshore engineering. So it's kind of like intertwined, the research. The more clear-cut research don't have a lot to do with the other trees is actually the last phase where I was looking at the human-centric engineering solutions. So there's overlaps of in between. And to sum all this up, of my 40 years of experience is that in research, the most important is to have good dedicated students like Suresh Bala and also their students. It's the students who make what the professors are. It's the students' own dedications, motivations, and supervisor is just very much working with them, and it's the students that make the supervisor. So thank you very much, Suresh and your team, and all of you, Yang Yao-Wen, Xia Yong, and everybody. Thank you very much. Okay, offshore. I started off, this was my very first project, and this was a model. In the old days, there was no beam, no virtual reality. So we have to, this platform itself costs about 20 million US dollars. So they have to make an actual model to visualize before building. This was a platform. And I was the engineer who built this, and I actually followed to the offshore to the Java Sea in Indonesia to launch it. This is a jacket, which was from here launched. And we use this derrick to pick it up, which is about 100-ton derrick. And then after piling in the jacket, we installed the top side. There's a top side. And so then the research I did those days was very practical. Very whenever there's a problem, you have to put together and find a way to solve it. Very practical, hands-on, direct application type of research. Then when I came back from MIT and I started off my actual research at NTU. All right, this was my test rig. huge test rig. You can see this green rig here, which is right here at the back. This is a big green rig. It's a multi-planar for multi-planar testing of tubular joints. Each actuator can exert up to 250 tons. This is static ultimate strength test for multiple joints, and this is my only PhD students working on multiple multi-planar joints ultimate strength behavior is Yisen Kai. And this is another of my rig, which is dynamic testing. This is the horizontal base, the offshore tubular base. You can see that, and this is the in-plane. Is dynamic testing. Is good for 30 tons in these directions and 25 tons in directions. Dynamic testing, and this was a rig before the painting. In those days, in the early days of NTU, we don't really have PhD students, so our main research force were FYP students, final year project students, and we do have some master's students, only one PhD student. So because that time NTU really only started research in the 90s. So in the 80s, we very much depend on the FIP students for research. All right, so for my research, I think the video has said that we actually won a Best Paper Award from the IES ISTRA-E. ISTRA-E is the UK institutions, and there's a president of ISTRA-E, Mr. Hill. He visits Singapore. The president of ISTRA-E will visit Singapore once in 2 years, and this is the president of ISTRA-E in Singapore. And this was actually my boss from McDermott. Together we worked on this paper, and then we actually won this paper award from our research. And we also published a book. This team of us published a book which was used as a reference book for my. I taught the offshore engineering course for undergraduate and also the master's course for more than 30 years. So this was used as my reference book. And we also provide short courses for the industries. For the industries, we have a lot of students. We also conduct courses, in-house courses for companies like Keppel and Sembawang for specialized courses for them. So there was very much, those days in the 80s and early 90s, NTU's research was very practical, very practice-oriented. We transfer directly our knowledge straight to the industries, because that was what Singapore needed at the time. The Singapore economy was just building up. So we need very practical solutions to solve practical problems to generate jobs. Okay, then my second phase of my research was computing in civil engineering, because I went to MIT. At the time, the hottest topic was knowledge-based systems, and it's commonly called the expert systems, and people don't use the word expert system anymore because the expert don't quite like that. So we went back to knowledge-based systems, and that was my master's thesis. And my PhD was with Wales. It was under this special arrangement, what we call the external degree, because I was then a lecturer in the British Commonwealth University. They still classify us as a British Commonwealth University. So we are allowed to have this special arrangement to do what we call the external degree. It's not part-time, not a correspondent. It's an external in a sense, because I was teaching in the universities. Okay, so but unfortunately, I didn't get to commercialize this software. My software was to automate the design of offshore structures. The best that came out from it was that I was nominated for the National Science and Technology Board Technology Award. I was shortlisted in the finalists in 1992, but I didn't get to win it. But that was the best is reached. But anyway, I applied this same research approach to teaching. So I was trying to use knowledge-based systems to come up with a teaching software to teach mechanics of material, because in 1993 I was a subdean in charge of students, and I found that weaker subject was mechanics of material. Many students failed mechanics of materials, so I was trying to produce a software to help them learn mechanics of material. So I was working with another of my colleagues, Ms. Yap Su Fong, who was in charge of the CAD lab. We were using C programming to write that software to teach mold, circle, bending moment, and all this. And it was very difficult writing all this teaching software by ourselves from basic, from C. And then in, I think 97 or 98, I was very fortunate that Ashok Gupta visited me as a visiting scientist from IIT Delhi. And then I was discussing with him about this teaching software, and he said, why don't we use existing platform to implement the knowledge? Yeah. So he actually got the Macromedia. Ashok, he got a Macromedia, and then that time I was teaching the first year mechanics course. So then we used that course materials, we implement into the platform macro materials, and we came out with this CD. We started off by putting it as a online learning free version for everybody, and it was picked up by the American professors, and they actually presented our case as a good example of what distant learning should be like. And that was year 2001. So we were actually way ahead of everybody in terms of e-learning and online learning, all because of my PhD thesis and master's and PhD thesis using knowledge base. So we're using the knowledge based system approach, and we use that to implement into the this Macromedia. And of course, we use a couple of my PhD students like Yang Yaowen and Wang Zhonghui to put in the materials. So that was how big the NTU Mechanics of Materials class. This is a 1,000 student auditorium, and the students was I won the teaching award in 2004. That was 1,800 students. We divided it into two classes, each class 900 students. The peak of this course was 2,400 students. That was a peak, and we actually divided it into 3 different classes, A, B, C. Each class has about 800 students. So because the class was so huge, so this teaching software came in very handy, very handy. And then and the student actually voted me for best teacher award because many of them like this software. And we are way ahead of many people. And unfortunately, I tried to keep Ashok Gupta back as a faculty member, but he said he's committed to IIT and he must go home. So because of that, we couldn't continue further. If not, we could have been a billionaire like this Indian teacher. I think his name is Baiju Ravindran, I think. According to the newspaper report in Singapore, I think this Indian teacher by the name of Baiju Ravindran, he started a company called Think and Learn Private Limited for education apps and became billionaire because of that. And unfortunately, Ashok didn't stay back to work with me, and then we could have commercialized our teaching software and become billionaire instead of just winning a best teacher award. Anyway, we also published the ASC paper on this. So we actually apply research to teaching to help us with our teaching, and the students actually like that. And I actually do that again in a later stage. I will come to that, using augmented reality to help with the teaching. Okay, then computing and civil engineering, I have my first PhD student, Yang Chaoping, a very brilliant student who helped me win the best ASC best TCC paper award. We were the first non-American to win the ASC best paper award. After us, there were the Swiss people who won also, but majority were all Americans, and we were the first non-Americans. My second PhD students, Wang Zhonghui, and then third, Yang Yaowen. We have a few also like Xi Qianfeng, Jin Zhanli, Wang Cao, Ji Changkuai. We wrote quite a few papers. In fact, according to this ASC journal, they actually compile. They find out which university, which country produced the most paper, which university produced the most paper. For the phase 3, they actually go by year period. For phase 3, which is here, 1997 to 2003, Singapore produced 12 papers. And these 12 papers, which is the most papers were from USA, 107, Canada, England, Singapore 12, and all 12 papers were from NTU. You can see that all 12 papers from NTU. Okay, I think NTU is here. Yeah, all 12 papers from NTU. So actually, that phase, NTU published the most paper in this particular journal, which is a big deal. Because we published so many papers that they actually invited me to be the associate editor from 03 to 08 because we published as a group. We published the most paper as a university in this particular journal. So something which we are very proud, because at that time, NTU, it wasn't that famous yet. It was still early days for us. Okay, then we came to structural health monitoring. I was very fortunate that Ashok got me this very brilliant student by the name of Suresh Bala. And he's a really very brilliant student. So also I've done something really good for me because he couldn't stay back. So he got me a very good student, a very brilliant student who have, for his master degree, he actually got the Singapore National Technology Gold Medal for his master degree. And for his PhD, he actually got the Young Researcher Fellowship from MIT from Professor Bartek, who is very famous finite elements professors. And his program, ADINA, is very well used worldwide. So it's a tremendous honor for Singapore students, Singapore Indian students to win this Young Researcher Award. And again, unfortunately, and our paper, our very first paper was for this large span concrete beam was actually picked up by the Council of Canadian Academy as a top 1% most cited paper in the world in 2011 in the world. And again, unfortunately, Suresh couldn't stay back. I offered him a faculty position, but again, he got to go back because he's committed to his family. So I gave him a farewell party right here. That was Suresh, his wife, at that time, no kids yet. So yeah, so I was very fortunate. There's students who did very good research that made me famous. All right. Then we also did a very big job of a large-scale monitoring. This was actually done by Yang Yao-wen. He and his team, I think, Lim Yi-Yan, Farrell, and then Vinu, and another very bright Indian students. They work on this large project. This actual case, this is actual stations, the Circle Line station at Telok Blangah. They actually measured this, applied the actual health, structural health monitoring to monitor these constructions. And Vinu and Yang Yao-wen actually published a book, and they were kind enough to put my name in with them. So this was our work. We actually applied them. Yeah? So it's very important that when you do research, it should not be just research. It should be applicable, which is so that people can benefit from our research. Right then, so this Vinu and this the other very brilliant. In fact, all sisters are so brilliant. So like Lim Yi-Yan, Vinu, Chui Ling applied to tubular joints, and then this is Liu Yi work on concrete by help me supervise Chui Ling. So Liu Yi-Yan, he is in Australia now, and he worked on this very difficult problem, fatigue life estimations. How to predict the remaining life of the structures. This is a very, very difficult problem and a very important problem to solve. For example, for offshore structures, they are usually used for 25 years. Some 20 years, but mostly are 25 years because after 25 years, they dry up the oil, so they don't need the structures anymore. So they are usually given concessions to extract oil for 25 years. Supposing after 15 years, and there was a damage, a boat came about and knocked it, dented one whole beam. So what should we do? Are we going to repair it or not? Because to repair is very expensive, very, very expensive, especially offshore structures, because most of the structures are underwater, under the water surface. So to build it, the structures are all built on land. I showed you at the beginning that my offshore work, that structures are all built on land. Then we tow it to the ocean. We then set it in the oceans. So 80% of the structures are underwater. So to do any repair underwater is easy 3 to 5 times more expensive, depending on the water depth you have to go underneath. So what happened? Are you going to repair it? Is it worth the cost? So if you can estimate with this damage, if you can estimate that, after 15 years you got a damage, if you can estimate that the damage can actually survive for another 15 years, that means it will be over your 25-year lifespan that you need to operate. So why do we want to repair? Why want to waste money and time to repair? Correct? So, but if you don't know, then you repair is so expensive and you have to shut down the oil productions. quite often when you do repair, you have to shut down the operations, and it's very expensive, because if a platform, let's say even a small platform that produces 60,000 barrels of oil a day, and you know the oil went up to 100 US dollars a barrel, so you know how much we are talking about, what, 60 million a day of a cost. So it's very expensive to shut it down. So that's why estimating the remaining life is very, very important. And Lim Yen did a very good job. Of course, it's a very simple problem we solved. And I was invited to give a keynote speech in Korea, keynote lectures for his PhD work. And I hope Yen can continue with this, because it's a very important part of engineering, to be able to do damage prognosis, to be able to predict the remaining life, so that you can avoid doing repair, and just keep working on it and just monitor to make sure it will not get worse. So this is a very important research. Okay, of course, we also have other students, like I also have another Indian student, Ashay Naidu. I have done very good work. I think he's in one of the Indian universities now. And also we have Chui Ling. Chui Ling, he did his work on the circular structures mainly for the pipelines, because offshore, the oil, once you drill the oil, you extract it, you have to send it to the shore or to the ship. You have to all transfer through the pipeline. So any damage on pipeline is very critical. It's just like your blood vessels. Pipeline in offshore industry is like your blood vessels. So we have to check the damages and all this. So it's like doing a real health check. So they have done very important work. And of course, Vinu spent the most time with me. I think he not only did his PhD, he was also my research fellows for more than 5 years, and he helped me supervise more FYP, final year project student, than any other of my students. And he was also a very lucky man, in the sense that his last 5 years with me, I essentially paid him for him to do anything he wanted. There was no obligation to produce any kind of results. So he moved on to do the work on metal materials, and and so he has published a couple of good papers, and I hope he can continue. But unfortunately, he's now working for a very big German company, German international company, I think Continental, and as a principal engineer there. So well, I hope someone can pick up this part of the research. Maybe Suresh's team can pick it up, the metal materials. I think it's very promising. The last part, he was not just only doing robotic arm monitoring, he also trying to use drone. Now the big thing is drone, using drone, so that we can use drone to do remote monitoring. So this is a part that we ended at for this part of the work. These were done by Yen. He went to Australia. I think he got good funding to do actual practical monitoring of this multi-story building, and his students was, because when you put sensors onto the reinforcement bars, the problem is the vibrations, the concreting, the mixing, the vibrations will damage it. So they have to come up with this type of smart aggregate where you can bury the sensors inside, so they will not be damaged, so that they can monitor the process, concrete curing process. And my contribution to this project was actually my last PhD student, Lucy Ping. His part of the work. There was his contribution, the smart probe and prism, and then I understand we were invited and by CRC to publish a book on this monitoring of concrete curing, and Lim Yen is taking the lead preparing the book. And I hope he can finish it up soon. Okay, so very much. So far, the research have been very practice-oriented, because solving industrial needs. Also, we have another group. Yang Yao not only took care of the research on the Teluk Blangah monitoring, he also helped me supervise quite a few of my PhD students, like Jing Zhanli, Xi Jianfeng, Wang Chao, Qi Changquan. They were applying, trying to do analytical and semi-analytical solutions optimizations onto health monitoring. So also looking at rock, and then we also collaborate with Zhao Jian, who is very well known for rock mechanics in both in Australia, Switzerland, and also China. It's very well known for this part of work. So, and we also from here we actually published quite a few of those papers in ASE and also the ASE journals, not just in the computing, but also in aerospace. In fact, Suresh also published, and Vinu also published quite a few of the structure health monitoring papers with the ASE Journal of Aerospace Engineering. Okay, then because of the experience in the large-scale monitoring, there was a lot of wires involved for the Torreblanca project. There was a lot of wires involved, and so in order to avoid those trouble, we are thinking of doing remote health monitoring. At remote health monitoring, you need energy. So Yang Yawen and his student Tang Lihua worked on this energy harvesting part. Energy harvesting, and then and they wrote a very good paper, which was in 2017 was the most cited paper in Journal of Intelligent Materials and Systems. All right, for the last 5 years, there was in fact this paper gave me the most citations, and this is Tang Lihua when I visited him, and also we have other students like Vita. Vita also work on this energy harvesting. So this is needed for remote sensing and control. Okay. Also for the offshore part, all right, I actually work with Jin Sun Juan, who happened to be a supervisor of Suresh's wife, and we co-supervise a PhD student, Eddie Tan, to monitor the jack-up rig. This is a jack-up rig, the parts. So when they do jack up and down, we are afraid that this might bend and collapse. So this is the oil, drilling in the oil. So if this collapses, the whole thing will collapse. And these rigs are very expensive, all right? Easily 30-40 million US dollars each, depending on the size and the depth they can go. All right, so this we use fiber optics, and I was invited by the Tianjin University and also the Chinese National Oil Synod, Chinese National Oil, to do a keynote presentation at their symposium in 2010, and also invited by Professor F.K. Chan of Stanford University. He holds this international workshop for structural health monitoring every 2 years. So for 2015, he invited me to deliver keynote lectures, and these lectures actually was published in his journal of SHM, and it was the most read papers. I think they track the number of reads because these are the e-papers. They actually track the number of reads. So it was the most read papers in 2016, 2017. And we summarize most of our work into this one particular book, and I wrote this, edited actually, because this book was a 3-generation book. 3 generations, because it's not just me and my students, but also their students, like Yang Yawen students, for example, Hu Yihang, Tang Lihua. They were all contributors, co-authors to the various chapters. And I think there were 21 chapters. And the first 3 years, okay, the publishers, because now the e-books and so popular, when people buy the e-books, they actually track the number of downloads. The first 3 years, we were in the top 25% downloads. Until this last year, 2020, we were still in the top 50. And it's a big deal. It's a big deal, you know why? Because ours is a hardcore engineering book, and it's not a reference book or a textbook. Most of the most downloaded books are the textbooks or reference book, but ours are very much a research-based book. So for it to be so well read, well downloaded, because they pay by the chapters and the book they download. So it's very impressive. And I was actually invited by Suresh. He organized this conference, invited me to give the keynote. And we actually presented this book to the first president of NTU, first president, Professor Cham Tao-Sun. He was my mentor. He was the one who hired me and sent me to MIT. And actually, there was a little story behind. When I finished MIT master degree, actually, Professor Connor asked me to stay back to do a PhD. And then I couldn't, because Professor Cham actually spoke to me and said that he has big plan for me. He said he has big plan for me. So I was a scholar, so he wanted me back and big plan for me. I don't know what was the big plan, but at least he introduced me to deputy president at the time. There was a deputy president, Tony Tan, who then went on to be the president of Singapore. So, so Professor Cham and him were good old friends, so they introduced me to the president. So that was very much this phase of our work on structural health monitoring. I think we have achieved quite a lot, and we have got international recognitions. All right, then publications. So actually, the health monitoring part brought me more the name, the fame. The offshore part brought me actually a lot of consultancy work. See, for example, my citations that Tang was have the most citations, and then the Suresh paper, the second most citations. So in fact, Elsevier did a ranking of the top 150 most cited researchers in civil engineering in the world. All right, and you can see the USA got 56 of them. Hong Kong and China actually should combine, because they just split up. Hong Kong and China, Hong Kong 18, China 6, so they should actually combine them. 24 is still behind USA. UK and Australia each has 10, and Singapore has got 4, and I was one of them. So because of the citations, and actually the emphasis on citations and H index was actually very much by the Americans, and the British were not very happy, so they came up with this few weighted citation impact, because the British believe that you should not just look at just citation and H index. You should look at what is the impact done within the field. That means you should compare civil engineering professors with civil professors, and not civil engineering professors with environmental engineering professors, or civil engineering professors with the chemistry professors. Because chemistry people, they publish almost every week, so unlike civil engineering. For civil engineering, the concrete to cure, you need at least 7 days. Operational is 21 days. So by then, the chemistry people already published 3 journal papers. So because of this few weighted citation impact, so the NTU research office actually do a re-ranking for us. And in the School of Civil Environment, I was actually ranked #1 ahead of all the environment people. Because environment people, they publish a lot of papers. They have very high citations and high index, but within their field, they're all high anyway. They're all very high. So for example, if the civil engineering professor like me, my citation of 37 is very high. In environment, a citation of 37 is just high, not very high, because their very high is like 90 or 80. You see, so they have to actually compare within their field rather than across everybody. So this is actually a more realistic way of finding out the impact of the professors. So among the College of Engineering in NTU, so I was ranked #7 behind these material science people and the computer engineering people. Some of them also have very high citations. So it's a fairer way of judging a person's impact, not just look at the citation and H index. You should look at the few weighted citation impact, compare them within their field. Okay, my last phase of my research is actually human-centric research. All right, so my first phase, actually, I look at efficiency. I look how to design structures better and better, more cost-effective, optimize the structures. All right, that was my first phase, efficiency. The structures are to be efficient, cost-effective. Second phase, monitoring. We look at sustainability. We want to monitor structures to help redesign it properly so that we at least it can be more sustainable. A lot of talk about sustainability also, not just in structural engineering, in building. They're looking at saving electricity, looking at LED, using LED rather than normal lights and all this, yeah? But then, have they actually considered the people using the structures, the building? Are they happy working inside the building? So that is the last phase of my research in the last 7 years, because like human beings, our demand for our living and working space, our demand, the standard keep increasing. It's just like us, human beings, evolving with our demands. Okay, so just like, see, 1,000 years ago, underground, this whole project was actually motivated by the underground program. Singapore is going into underground in the last 10 years, going underground in a very big way, putting a lot of money, because Singapore is very small and there's only that much land we can reclaim from the sea, and also that tall a building we can build, because we have 3 air bases, airports. So we cannot build too high, because or else the plane cannot fly. And so we cannot reclaim too much, or else we'll be reclaiming into the neighbor's shore. So we have to go underground. And the demand for underground has increased over the years. Look at here, for example, Paris. Underground was used as a cemetery 1,000 years ago. But now look at this Paris. This part is actually underground. And this is above ground. This whole is shopping mall. All right, it's very much like Singapore's ION, ION, ION in Orchard Road. Except ION has this built like a glass pyramids that built on top. So but ION was deeper. ION went down 6 stories. This is about 3 stories, 4 stories. Okay, so the demand for underground, we're going to use underground, but the demand for it, the architecture, the engineering part, will have to keep increasing, because we want to have higher and higher standards in using the underground space. So we want people to be happy to use those space and not just efficient and sustainable. Right? So what is the significance? For example, in the workspace, from our research, we found that our research results apply not just to underground, but to any enclosed building. For example, a large factory, where you enter the factory when you are not near the window, and you spend most of the time inside, and then you go to eat lunch within the cafeteria inside the building, and evening then you go home. So there's actually no difference if you are working underground. So our research results actually applicable not just to underground, but also to above ground, as long as you're enclosed place. And what is the significance? The significance is that if you don't have a good working environment, all right, the physical, psychological, and stresses will affect your work performance. And in Singapore, it has been found, this by the National Health Ministry, they found that it costs Singapore about 3 billion a year, our economic losses due to the stress-related illness. Stress-related illness contributed to about $3 billion losses cost in terms of health costs. And also the psychology stresses affect the sleeps, all right, affect the sleeps. When you are stressed at work at night, you cannot have a good night's sleep. Even you could be lying on the bed for 8-10 hours, you don't have a good night's sleep, and that causes your productivity drop. All right, Singapore doesn't produce a figure, but this figure came from this one is Singapore figures, correct? Okay, Singapore estimated that the loss in productivity per worker is about $2,000 a year annually lost due to poor sleep. And how do we confirm? Okay, we actually checked this from our research project. I will explain later how we come up with some figures to prove this also. Obesity, all right? Also work stress causes people to eat more. They find their comfort in eating, in drinking hot chocolate drinks and all this, so they have obesity problems. Singapore doesn't have the figure, but this figure came from the United States. United States has a very big obesity problem, all right? Apparently it costs them almost $147 billion worth of medical bills just on solving obesity problem. That Singapore has a problem. 55% of Singapore population has a high BMI of over 23 like me, which is not good. We have to reduce this. Okay, the other thing about building is a sick building syndrome. I think many of you are familiar. especially if you go into the office on Monday, the aircon were not on Saturday and Sunday. So Monday, the air were not clean. So many people feel sick. On Monday, by the time after lunch, you're all feel tired. They call it the Monday blues, but actually has got a lot to do with the building. Okay, and this caused a lot of production costs, sick, building syndromes. In USA, it translates to about $60 billion of losses in terms of productivity. So a bad working environment, a bad living environment has direct impact on your productivity and cost to the economy. All right, so this is the motivation behind this last phase of research on human-centric engineering solutions. All right, so we actually approach it holistically. We look at, I'm in charge of the built environment. We have psychologists. This is a psychology professor, clinical psychologist. He's a medical psychologist. He's holding dual appointment with Imperial College. He was an Imperial College professors, and he also joined us as he has dual appointment. And we have a sociologist professor, because the sociology does impact how we behave and react towards our working and living space. And I have this, he was a former chair of the School of Computing. He's working with me on the virtual reality, because we don't build model. Remember, I told you with my first offshore platform, we actually built a model, a real scale model. But now we have virtual reality and BIM combined, so we can visualize everything before we build them. So we can actually visualize this and then test the people according to our virtual reality, in our experimental tests. All right, so we actually studied the various factors by all the various people, and we found that the common denominator is the lighting and the sunlight and the circadian rhythm that cause the most common problem. And culture, people are surprised that why culture is important. Culturally, that's very important. For example, going underground. Southeast Asians don't like to go underground. For them, underground is related to death, funerals and all this. But in Japan, underground is good because they have earthquake. So underground is for them is safe. And in Midwest America, they have tornadoes, hurricanes. So underground is very good for them. So culture is very important. I think my time is up, is it? So I better talk faster. So, right, Suresh, my time is up, is it? Okay, anyway, I'll do a quick one.
You can continue. You can continue. No issues.
Okay, this is a big program. It's actually $5.5 million over 5 years. So it's a huge program. So we actually visited 4 different countries. We visited America to find what they have been doing with the underground work. We visited Sweden and Norway. We also visited China to learn from their mistake. And no point making the same mistake. So we went there, we spent weeks with them and learned from the mistake. We actually did this is an online survey done by a professional psychology company. They have done this. They actually work over 4 cities, more than 2,000 participants. I will explain this in the next slide, what we actually do with them, 4 cities, and what we actually study with them. And we actually do the cohort study in Singapore. Almost 500 is more than 400 is almost 500 workers. About 150 are underground workers. 300 are above ground workers. We actually test them over 700 parameters in 3 ways. We do 3 tests over 1 whole year, and including taking their blood, taking their urine. We actually test them to find out how it affects their melatonin, how it affects their health. So we actually physically test almost 500 workers. We actually done experimental studies on more than 1,000 participants at NTU. This is our underground lab. We actually have this brainwave scan to scan their response when doing the experimental test using virtual reality and actual experiment. More than 1,000. Mostly are NTU students and the staff. Very few are faculty. They don't want to be checked on their brainwave. All right, so this is what we have done in the international survey. More than 2,000 participants aged between 18 to 65. We study in the Singapore population, London, Shanghai, and Montreal. This is done by a professional company to help us collect all these data, look at the nature, the concept of space, personal response, altitude, attitudes toward underground space, and they have a whole series of check and cross-check because they are very professional psychological testing company. They want to make sure they don't tell lies, because it's very, they can always say things that to please people. So they have cross-check parameters to cross-check them. For the cohort study, for example, we took their urine, we took their blood. We also study how often they drink. We actually do the breath test. So how strong is their lung, whether they smoke. We check their heartbeat, and then we actually let them wear this wearable, wearables, artigraph wearables, 2 weeks. Every time they have to wear 2 weeks, 24 hours every day for 2 whole weeks. Even bathing, sleeping, they wear it so that we can monitor their heartbeat, their sleep rate, and all this. So we actually monitored 142 underground workers and 322 above ground workers. We actually studied almost 500 people, and also we do the lab. This is our physical lab, and this is our physical the lab, and we actually use the lab. This is a virtual reality. This one looks the same to me. Okay, this is a real lab. This is a virtual reality. So we actually found that we can use virtual reality to fully simulate the actual lab. So we published this paper in the psychology journal. All right, we do the artigraph testing also while they are doing the test. Not only we do the brainwave, we also we monitor the brainwave, EEG, the EEG, and then we also measure their heartbeat, heart rates to check them. So we actually tested more than 1,000 over 2 years. These are mainly students, mainly students. Of course, students, we cannot pick them anytime before exam, after exams, but it affected them, their performance. All right, so we actually combine brainwave response with virtual reality and design and engineering to actually change the parameters here. Okay, so these are the things we did. Okay, we have even eye tracking. You see this eye tracking? We have the eye tracker. This is the underground tunnel in Stockholm, Sweden. So we actually see how these people respond. Can you see the dot? That's where he is focusing. All right, see this dot? This is where his eyes is focusing. And we found that the male and female have different focus. All right. All right, this is Stockholm. This is in Stockholm. All right, so male and female actually have different focus when they look at things. All right, male tend to look at the overall picture, and female tend to be more focused. So from this study, we actually, okay, all right. Okay, anyway, these are all the things that we have done. We have virtual reality, we have actual eye tracking, the real field. We have actual psychology, computer-based tracking in the lab too, and then we also do the melatonin test, urine, blood urine, and melatonin to see how it affects them working underground, working without sunlight. Okay, these are all the various tests. We also look at spread of disease underground. In fact, we were doing this 5 years ago before this pandemic was going on. We actually look at how within the enclosed place how disease was spread. So we now can give advice on how to redesign structures for social distancing in case there's another outbreak of this COVID pandemic. Anyway, we summarize all these results. Too much to explain to you. So these are some of the things we found in China, in USA, in Europe, and then we combine with what we found and see what's the differences. Because, okay, why we said ours is the most comprehensive study in the world is because for other people, we are not the first to be studying this. I must make it very clear, we are not the first, but we are the most comprehensive because other countries, what they have done is that they study by part. If they have a health problem, they only look at health problem. If they have a psychology problem, they look at psychology problem. If they have a social problem, they look at social problem. If you have the architectural problem, they look at architectural problem. They do not put them together to study holistically. All right. First of all, one reason I found is because they cannot get such a big sum of money in one go. Second, also, it's very difficult to find medical doctors to want to work with psychologists, psychologists to want to work with sociologists, and sociologists to want to work with civil engineers is not easy, right? I'm able to put them together probably because of my seniority in the universities, and I'm able to put the whole team together, but it's not easy because I can tell you that the medical doctors, all they ask for is money, 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 money all the time. All right, so it's not easy project to work on. So anyway, we came out and we found that ours is the most comprehensive so far based on literature review. Of course, the military people have their own very comprehensive study, but they're all classified. All right, so I'm only comparing with what is available on open literature. Open literature, the military, the submarine people, the nuclear people who run the nuclear silos, they are what we call the extreme conditions. So we are not comparing with the extreme conditions people. These are the extreme. We are not, yeah? Okay, we are doing the general civilian use and based on public information. So based on this, we are the most comprehensive. So we actually review over 300 papers. And from here, we put in our result and we published four journal papers out of the review and using our own result and our own associate models. So Singapore put in so much money into underground, so they actually produced a program under the channel News Asia. You can actually go YouTube and download this. It's called Going Underground. The full episodes is what lies deep beneath Singapore going underground. If you type this in the YouTube, you can get this. It's in a 1 hour program. I think it appeared for about 10 minutes. That was me interviewed. This is the clinical psychologist, the Greek man. This is my senior research fellow. Is an Englishman from Yorkshire. And then this is the one I was talking about, monitoring the brainwave EEG. And it's very expensive. We have 2 sets of this. One set is, I think, $100,000 US. One set for indoor. Indoor is linked to all the computers, and one set is for the outdoor. That when we went to Stockholm, when we went to China, we brought it along to monitor some of the people to compare it with them. And also, we went to the site work. We also monitored them. This for the indoor for the labs. And this is a virtual reality. We actually test on virtual reality in the actual lab, and we use a virtual reality and we check his psychological response. Right? Remember, I told you there's this psychological test. He's a clinical psychologist, professor, actually from Cambridge University. He came crossover from Cambridge University. Okay. Adam actually came from Oxford University. He was with the linguistic department, diagnostic, how to teach language in Oxford University. So he's actually a psychologist himself. Okay. So the concluding remarks is when we build an underground space, this is Rama, my visiting scientist. I think Suresh's PhD student. So he helped me with the earlier part of this, looking at the underground built environment. So the conclusion is, do you want to build going underground is so expensive. To build underground is at least 3 times the cost of building upwards. So when you put in so much money, you want it to be empty, where only the user would go, or you want it to be so crowded where people want to go. This is actually inside the Marina Bay Sands, the iconic building in Singapore. This underground cafe. This is like 4 stories underground, and it looks like ceiling above ground, but it's not. It's just a fake ceiling. This fake ceiling looks like it's the sky with the sun, but it's not. The lighting are all fake. Just our lab. Our lab here, the ceiling, these lights can be changed. We can change to blue, to orange, so we can change all these lights to morning sun, evening sun, night, all the lights. And these are fake windows. These are all fake windows to fake them. So because people want to be connected to outside. So we can actually study the response from the brainwave. And people cannot lie about it. Because according to George, he's a clinical psychologist, this brainwave, your response in the brainwave is almost immediate. For example, when you ask this guy, are you hungry? It will immediate response before he can tell you whether he's hungry or not. Because when he want to tell you, he go and think about it. He may not. I mean, depending on the situation, he may not be willing to tell the truth. You see, so here can actually pick it up. All right. So this is our conclusions. So our few and okay, so far what we have got is I've been invited to deliver keynote speech lectures twice at ACUS. ACUS is probably the biggest underground conference in 2016 in St. Petersburg, Russia, and 2018 in Hong Kong. And my researcher, Miss Dr. Suin, actually got the young scientist, young inquirer, young scientist, the same thing award. I think she's now a assistant professor or associate professor in Guangzhou University, and this is George and us. This is the president of ACUS. President of ACUS. All right. Our next phase is that we want to actually customize your workspace. We want to use AI to actually tune the lighting according to your needs. So we actually physically monitor your physical response, whether you are when you are down, all right, you are depressed. We can actually change the lighting to brighten you up. We can change the air conditions. So we want to customize all the workspace for you, and so that your productivity can improve, rather than right now the whole thing, because of sustainability, they want to save electricity. They use LED lights for office. You know, it actually affect the performance. How much electricity can you save? You know, the manpower cost is the most expensive budget for a company. For example, NTU, the manpower cost is more than 75%. So electricity, how much can it be? 10%? Even you save 100% of 10%, but your productivity drops. You know, your productivity drops, then it's not worth the saving. So we should increase the productivity, make the people perform much better, try to customize the workplace, not just the lighting, but also the air conditioning, the room sensors, the air quality. So then we can also customize to the bedroom. People can sleep well, sleep better, and then they can perform better. So that's why we call it a human-centric approach to engineering problem solving. All right. So from research, like I told you, I always try to apply my research to teaching. So we spend quite a bit of time doing virtual reality. This is actual virtual actual space. This is actual lab. This is our virtual lab, and then we can actually change the parameters. You know, we publish papers in this psychological assessment journal, and then they accepted that we can actually use virtual reality to emulate the actual space. So when I want to apply to teaching, again, my very important part of as a professor's job is to teach well. So with ASHO, I came out with these teaching software apps, but then now I found that most students, if not all students have a handphone, and they spend more time on handphone than on anything else, other than probably the computer, but probably handphone more than even the computer. So if we have augmented reality, use augmented reality for students to learn. So this is my lecture notes. This is my lecture notes on structural analysis. All right. So if we can actually, right now we actually video our lectures, our tutorials. But if students can actually use augmented reality, they can actually study while they're on the train. So handy, right? Because on the train, what they do, they watch movies, K-pop, more K-drama. That's what the students first love these days, to watch K-drama on a train. So if on the train they can actually study, right? All they need is a set of lecture notes and use augmented reality, and they can actually study to help them bring the lectures right to them. So no excuse for them not to study anymore. So this is a prototype, as a working prototype, and I hope to expand this. And maybe I can find someone as good as Ashok to come and help me commercialize this part, and maybe we can be as rich as this Banyu Ravindran. Okay, after 40 years, my reward is what? As a fellow, it's a piece of paper, right? A fellow, the national award, a piece of paper, and the current chair, give me a photo. That's about all. But anyway, what I'm trying to tell you here is that don't neglect your family. Don't neglect yourself. It's a home. Home is a base to everything. It's my home. All right. So no matter how well you do your work, your home will be where you have to go and have a good rest. Then you can do better the next day. So don't neglect your family. Don't neglect your home. So no matter how well you have done your research, because at the end of the day, It's just pieces of papers. All right, and friends, you know, when you have, after your work, resting at home, what is more important? Really your friends. So I try to turn all my students into my friends. This is Suresh's wedding and Xi Jianfeng's wedding. Their wedding, I throw them a party. I invited the deputy president, who was also the dean of the school, Chong Hee Kian, to come. And I think there were more people. I don't know, probably outside somewhere. Not all of them showed out in the picture. There were more people. These are our kids. This is Jin Sun Juan, Suresh's wife's PhD supervisor. This is Li Qingmei, Xi Jianfeng's wife's PhD supervisor. This is my wife. So, and also I very often I organize party for all the students. This is, I think he's from Turkey. This is Vinu, Zhang Lei. These are all our students. I used to bring them together and bond with them, you know, so treat them like friends. And they got married. I visit them, and then they show me their children's photos, you know. And these are my psychologist group. Their birthday, I buy them birthday cake, throw parties. So treat all your students and the research as friends if possible, so that 25 years later they can organize a conference and dedicate it to you. All right, and not only my own students, and I was a head of division for more than 10 years, and these were all the researchers at that time. I also throw food receptions for them. You know, in Singapore, the bonding is very much through food. So I organized food for them, and in fact, this was all the students from Shanghai Xiaotong. The biggest group at the time when I was head of division was the students from Shanghai Xiaotong. That year, I invited 3 vice dean of the Shanghai Xiaotong, Liu Hua, Xie Xiaohe, and Huang Xingchun, the 3 vice dean. And I invited all the Shanghai Xiaotong students. I think there were about 30, 40 of them, but I think some of them were outside or somewhere. They didn't take a picture. So this is, I think, Xi Jianfeng. Yeah, right. So this was the first PhD, not my first PhD student, but the school first PhD student. All right, I was a sub-dean at that time, and I helped the wife look for a job. The wife was also a master's student. I helped them look for a job, so they were so thankful. So every year they sent me Christmas and New Year card. You know, these are some students that we became friends along the way. All right, and then this, he's even more so patriotic. This is Vinu, and he going to show me how much he loves Singapore. He couldn't hang on to me, so he hang on to the Singapore flag. Anyway, this is Vinu. He helped me supervise. He's the one who spent the most time with me, I think. As a researcher, of course, Yang Yao wouldn't spend the most time. As a researcher, he spent the most time, and he helped me supervise the most FYP students. These are all my students. She's now a principal engineer with the oil company in Houston. They send me Christmas card every year. And this is Lu Xingzhen, his Tsinghua University, and he's not there. They send me, keep me as friends. My students all became my friends after that. Of course, my Wang Chao Ma Han. These are the two, my 2 bodyguards who will lunch with me practically every day until this pandemic came in. And this is the current dean of the College of Engineering, NTU's current dean of college. He was my student. I taught him mechanics, first year mechanics. He was on mechanical and aerospace engineering. So he was my student. And then this Yang Yang was a professorship. So we were together, took some pictures. And this was the student, because I was a head of the division for more than 10 years, so many of the PhD students were actually recruited by me, like Singh. I recruited him from Southeast University, and I didn't know he was dating Yang Yang student Hu Yang, and they got married, and they sent me pictures. And this also, of course, Yang Yang student. My student belongs to the older generation. Will not do that publicly, even on wedding days. Okay, so this is my last page, paradise. All right, what I'm trying to say is using these 2 Chinese phrases. This Chinese phrase says, if you view the world with a happy heart, and if you view your life with a grateful heart, then you will have paradise with you. Right? You don't need to go to heaven. Paradise is not in heaven, it's right here with you. If you view the world with a happy heart, and if you view your life with a grateful heart, then you are actually living in paradise. Thank you very much. Thank you.
So thank you, Professor So. That was a very enlightening presentation. And Professor So, he's always refreshing and full of ideas. You talk with him 5 minutes and you will get 500 ideas to do research. So Professor So, he's so active in everything, in socializing, in research. So he's an all-rounder. And for him, age is only a number.